All right, so off we go. What we're going to be talking about today is a feature. It's a library in Python, like we used the math library before. This is going to be called the turtle library. It's a very funny name. It's a very fun metaphor. I'm excited to teach it to you. It's going to make it, it's the closest essential equivalent to Scratch that I can give to you. So I'm excited, all right? But before we get there, let's just get some examples writing slightly longer Python programs, doing cool stuff like we know how to do. Let's get some input from the user. Let's do something interesting with it. Let's get practice using variables, all that fun stuff. So learning how to do this in Python. All right, so here's just a silly example. Let's ask the user for two things. And so we're going to use the input function. All right, we're going to ask the user for two numbers. And so we better put real numbers in like a num1 and a num2 variable somehow. We're going to get two numbers from the user, and let's compute the first number to the power of the second number. So for example, if the user gives us 2 as the first number and 3 as the second number, we'll save those away safely somewhere, and we're supposed to spit out 2 to the power of 3, the first number to the power of the second number. And so we should say the answer is 8, back to the user. Okay, so that is going to be our first example. So remember that to do power, I think I already told you this, but let's open up idle, and I'll just show you it on the REPL quickly, if it wants to start. So this is not a program, this is just the REPL where I can write single lines of Python code. I don't write a full program here, but I can just write a single line, like 2 * 3, to remind us that this double stars is not multiplication, it is to the power of. So that's 2 to the 3rd power, 2 to the 100th power is apparently whatever that is. So it all works out. And so yeah, let's do that. Let's write that program. This may not sound very exciting, is the first thing, right? We've done so much cooler stuff in Scratch. Why do we have to go back to math now? So that's the one downside about learning a new language like Python that's very, very different from Scratch. We're going to have to write some simpler programs so I can build up the knowledge of a text-based programming language in your mind. All right, so unfortunately, Scratch was very nice to us. In general, it's going to take a whole lot more code to write the same Python program that matches some Scratch program that you wrote before. And this is true about any language as well. All right. Every language is harder than Scratch. Scratch was meant to be your first language, so it's a bit more low level, we say. Okay, and so yeah, let's get some numbers from the user. Let's ask him for stuff. Let's save them away into a variable. I'm going to say file new, so I have a new file to work with, and I'll save it somewhere. I'll call it POW for power or something. And so I'll make a folder for today's lecture, and I should probably figure out what lecture we're in today. Lecture 14. All right. So I'm going to give this to you, so I'll put it in a special place, but you can put yours wherever you'd like. Desktop, code from class, 601, lecture 14. There we go. And I'll call it pow.py. Pow is short for power. Why not? Okay, so let's get two numbers from the user. That's our goal, right? Get two numbers from the user and compute the first one to the power of the second one. So let's get the first one. I'm going to say input and then give the user what I would like. I'll give the user what I want to show them while they're typing. All right, so I'm going to say enter the first number, something like this. And so they're going to see this. When this runs, they're going to see this little prompt and a little space afterwards, and that's where they're going to type. And input gives you back the answer that the user gave you. So you can save that away into like a num1 variable. Okay. Oops, I'll just call it num1 and set it equal to whatever input gives me back. But remember, this is supposed to get the first number from the user as an int. So num1, if I just print the type of whatever num1 is, anything you get back from input, let me run this, anything you get back from input, even if it's the number 2, it made the string 2 and it put that in num1. It's essentially said num1 equals the string number 2 with quotes. That's what input does. It gives you back the keys that were pressed, the characters that were given to you, even if they're digits. So if I want to use num1 like a number, I better convert its type from str, which was a string, and that means characters. I want to convert it to an int. Okay? So I'll say int of whatever I get back from input, and that will convert it to be an actual number that I can work with. Okay? You remember that? So that's the goal. So whatever we get back from input, that's a string. It's just characters. If I want to do math with it, I better convert it to a number type like int. Okay? Assuming we're getting whole numbers. Does that make sense to us? That conversion? Is it coming back to us? Input always gives you a str. So that's the first number. The same idea applies when we want the second number. Second number, enter the second number. And we'll call that num2. And again, we want it as an int. Okay? And then finally, after these two lines have run, then I have these variables holding actual numbers, and I can do stuff with them. I can say num1 star star num2. That's going to be our goal. All right. So finally, calculate num1 to the power of num2 and print the result. All right. So this is not the REPL. If I want to show something to the user, I have to wrap it around this print function call. And so I'll say, I don't know, num1 star star num2 as the one thing we print back out. Okay? So if I run this, I can type F5 if I want to run it quickly. See how it says run module F5. I'll do it slowly the first time. Enter the first number, 2. Enter the second number, 3. You hit enter to give it to the computer. And so now it got 2 and 3 and num1 and num2. It computed that to the power, 2 to the power of 3, and that's our 8. You can do it the other way, like what's 3 to the power of 2? That's of course 9, and that is that. If you'd like it to be a bit more pretty, remember that you can give multiple things to print. You'd be like, here's one string, and then I can put a comma and it space separates the other stuff. So it's like the result is, and then a comma, just anything that you comma separate, it's going to be space separated in the output. So it's like compute this, put it right after this, after a space. So if I rerun it now, 2, 3, the result is 8. That looks a bit more clean. Something that the user could understand better, maybe. Now they know. So that's our first example of the day. So getting 2 numbers from the user, doing some math with it, and spitting out that answer after we've computed it. Are there any questions about why this translates to this output? And of course, it works different every time if you run it with different inputs. All good with that? So yeah, that's just Python again. So to make a variable, you use this equality. And then to show something to the user, you always have to say print. Right? The REPL is nice to us. It's a read, evaluate, print loop. And so it's automatically going to print the answer. But in a normal program like this, you got to say print when you want to show something. Okay? All right. So let me just write all this stuff down. So remember, all that conversion stuff. To make an int out of a str, you say int. You call it like a function. Because when you do this, when you say input, I'll just write this down so you can see it here too later when you study. Input, then you give your little prompt, and that's what's displayed to the user when you say input. And it always gives you back a str. So it's like it gave you the quotes 42, unfortunately. And so if you want to get an int form of whatever was given to you, you got to wrap your input call, which had its prompt as usual. You got to wrap that in the type that you'd like it to be converted to. Int, input, something like that. And then you can set that equal to like your num1 or your num2. Num1, let's say. Okay. So yeah, that's that all over again. Hopefully that's not too bad. Okay, so now I'm ready to show you the cool stuff for the day. It's called the Turtle Library. You can search for it and go to this link. And that shows you all the functions that exist in this library. So like Python, Turtle, I guess you can search for. And the first link is the documentation page for the Turtle Library. And it is very beautiful. It's going to give us the ability to draw stuff onto our screen with Python. So that is our goal, all right? So it's called the Turtle Library. It's a very, very fun name. It was invented before Python, back in the day with a language called Logo that was meant to teach people how to program. This turtle idea was meant to be a way to teach programming. And so obviously I'm going to steal it and use it in this class too. So the turtle library revolves around this silly little metaphor. There is a turtle. I will draw him in green. So here's our little turtle, and I don't know, here's his shell. And he's got a little tail, and he of course has feet and things. So there's our turtle, happy little turtle. And somehow, well, I'm not naming any names, but somehow this turtle's tail got dipped in ink. Okay, so the turtle has like some blue ink on his tail or something. And this is not a normal turtle. This turtle understands English. It understands your commands. So it's a trained turtle, and it can move in whatever direction you tell him to move. And you can ask him to put his tail up or put it down so that he can make some marks while his tail is down. If you ask him to walk while his tail is up, he'll of course make some not marks. Ask him to put it down later, I guess. So he could leave a trail that's like dashed if you wanted it to be dashed. And you could have him move up and down, left and right, and draw different little pieces, little pictures. Okay? Isn't that cool? So that's going to be the idea. We're going to talk to this turtle. Hey, turtle, move forward, move backward, turn in this direction by this angle. Put your tail down to make marks. Put your tail up to not make marks. That sounds kind of cool, I hope. So that's where we're going. And here's the turtle library. This documentation page kind of tells you what's going on there. It's like, all right, tell the turtle to move forward. Tell the turtle to go left by 170 degrees, stuff like that. And so this example program, for example, is going to draw this very cool output. And you can make it even cooler. So yeah, there's a bunch of different turtle functions. There's always your current turtle. You can say like turtle dot move forward, and you can click and see what that means. There are certain functions that are like copied into other names. So like you could say turtle dot forward or turtle dot fd if you didn't want to type too much that day. Either one would do the same thing. So it's like go forward by a certain number of units, go backward by a certain number of units. And so here's like turning left and right. Turtle dot turn right by 45 degrees, for example. Turtle dot turn left by 45 degrees. So I encourage you to read through all this. It's a very interesting idea, but that's going to be the bulk of what we're going to talk about today. Just forward, left, turn right, and then up and down, put your tail up, put your tail down, stuff like that. All right? So yeah, without any further ado, let's have the turtle draw a square, because the turtle will respond to our commands. Let's make this happen. So let's see here. There is a concept of once we use the turtle library, it makes a brand new window for us to draw on. So like there's a window that opens up, and then there's a turtle that like appears. So there is a coordinate system there. So like the turtle's in the middle of its little coordinate system, in the middle of the window. That's where the turtle starts his life when our program begins. And he starts out in the middle at like 0, 0. And he's facing east, so he's facing to the right. If you asked him to move forward, he'd start making a line in that direction. Okay? And that's the idea. So there's a bunch of dots that we're going to have to use again. So like, hey turtle, turtle dot forward, turtle dot backward, turtle dot left, turtle dot right. Remember that the dot corresponds to like apostrophe S. Run the turtle library's left function. Run the turtle library's forward function. All that kind of stuff. All right? So yeah. That's what the dots are for. It's like the functions belong to the turtle. Like, hey turtle, what's your position? That's kind of the idea. Okay? So let's get started with this, I guess. We'll figure this out together. So I'll make a new file, and I'll say file new in idle, and I'll save it and I'll call it square.py. The one thing you can't do is call this turtle.py. Do not call it turtle.py because we're about to include the turtle library, and if you save a file with the same name as a library that you want to include, it will shadow that name and it won't work out. So don't call this turtle.py, whatever you do. All right. So the very first line is going to be import turtle. That's the library that we're about to use here, and it makes the turtle appear on its screen. And we can ask the turtle for where he is. He knows where he is. Turtle.position tells us that. Position. If I'm spelling position right, I hope I am. And of course, if we want to see that, we should print it out to our terminal output little screen there. So if I run this, some interesting things are going to happen. First of all, there's a window that pops up. This is the turtle window. Oops, go away. I want the other stuff back. There we go. This is the turtle window. So like here's my program window. I can write the program. The REPL's always there, and it prints the position. Like there it is. It prints the position. That's what we're outputting. And then this is the new window. It's the turtle window. So here is our turtle. He's a little arrow right now if you don't want to change him. But that is him. He is in the middle of the screen at coordinates 0, 0, because his position says it's at 0, 0, and he's facing right. And we say east in the turtle library to mean he's facing right. Okay, so that's a good start, I think. If you don't want the turtle to look like an arrow, which is not as fun, let's make the turtle look like a turtle. You could, if you scroll down, there's some different options here, and one of them is the appearance. I can say turtle.shape and give a string of what I want him to look like. So it can look like an arrow, a turtle, a circle, a square, blah, blah, blah. We're going to make him look like a turtle. Why not? So, hey, Mr. Turtle, please look like a turtle. Turtle.shape. Become a turtle, please. That's cooler for us. So make the turtle actually look like a turtle. And I'll run this with F5 to do it quickly. And so now he is a turtle, and he's facing right, of course, at 0, 0. That's where he begins his life. Okay, so yeah, let's get some practice with some of these different library functions. So probably the simplest one is just, hey, turtle, move forward. Turtle.forward, and then you give some amount. And there's a unit system you'll have to figure out depending on how big your screen is. But I'm going to ask the turtle to move forward by 100 units. All right, and here's how you do it. Turtle.forward, and you give an amount. And this is saying, Mr. Turtle, please move forward. Please move in your current position, your current direction, 100 units forward. Please move in your current direction by 100 units. And of course, his current direction is to the right, east. So he's going to move to the right that amount, and by default, his tail starts down on the page, so he's going to make a line. That's the first line, and there it is. Does that make enough sense? And now, of course, he's in a new spot. He's moved over. So if we ask the turtle for his position now after we've done this, it will have changed from 0, 0 to be like 100, 0. Right? Because he went over by 100 in the positive x direction. So that hopefully makes enough sense. Here's all these at once. Any questions about any of that so far? There's the line that we drew. There's the beginnings of fun art that we can make for ourselves. All right. So our goal is going to be to draw a square. That's my silly first example. So the turtle started here. Go away, zoom window. There we go. The turtle started down here at like 0, 0. And we just made him do this, right? His initial direction was to the right. And so we just drew the bottom part, maybe, of a square. And so this was 100, 0. And he's still facing right. Does that make sense? If we would like to draw this square, of course, we would like to draw this particular square. Pretend it's a perfect square, please. We need to get him to, turn so he can move up to here. This will be 100, 100. And then this will be 0, 100. Okay? So we just moved him right. Now he's sitting right here, facing to the right. So if we tell him to go forward anymore, he's going to go off here. And we would like to draw a square, so that's not good enough for us. So we would like him to turn a little bit. He's currently in that direction. Turn by this amount so that he's facing this way. So when we tell him to go forward, then he'll go straight up. And that will draw the rest of that. So this is a 90-degree angle, of course. We should tell the turtle, hey, you're going right. I want you to go up. So turn left, please, by 90 degrees. And that's how we do it. Turtle.left. And then you give it a certain degree amount. Oops. There we go. Okay, now it's happy. Okay. So to turn left 90 degrees, so that's the next thing we need to do. Turn left 90 degrees. We say turtle dot left 90. All right, turtle dot left 90. And now when I run this, you see how he's facing up? He hasn't gone up, but he's ready to. If I tell him to go forward, he's going to start making marks in the up direction. And that's what we'd like to do. Okay? And so, essentially, if we want to square, every side better be the same length. So this better be size 100, and then this better be length 100. So go forward again, Mr. Turtle, 100 units in your current new direction. And that'll be two sides of the square now. You see how he's working? And so I think you understand the game at this point. It's like, all right, turtle, now turn left again by 90 and go forward some more. See if you can complete it before I finish explaining it. And then, obviously, once more, he needs to turn left 90 degrees, go forward, because that will be in the down direction at that point. Copy, paste. And now we have made our square. Look at that. Isn't it beautiful? Any questions about why this code draws the square? The possibilities are endless with the Turtle library. Once we learn fancier things, you can make really cool graphics. All right. Let's see here. Yeah, if we're good with that, here is, here's this. I'll get rid of all that. If we're happy, I would like you to take my code and draw a second square. All right, so I'll give you my code. I'll open up Discord or something. It will probably take forever to load, so let me explain what I want you to do right now. I would like you to draw a second square. So like, here's our first square. Maybe draw another square over here. Or, I don't know, draw another square over here. Or you can draw a little square inside of your square or something like that. Or a bigger square outside. That's going to be the game, okay? You will probably end up needing turtle dot up. That tells the turtle to pick his tail up and not make any marks when you move him. And then turtle dot down asks for more marks now. Just without anything between the parentheses, you just call those functions like that. And yeah, so that's that one. So try and see if you can get that working. There's also a concept of turtle.setHeading. Instead of saying go left by 90, go left by 90, go left by some amount, go right by some amount, you can say, hey, turtle, immediately change your direction to a certain degree. So like 0 degrees is face to the right, face east. If you say turtle.setHeading 90, that makes him, no matter where he is right now, face up. If you say turtle.setHeading 180, that makes him face left always, or west. If you say turtle.setHeading 270, that makes him face down. So that's another thing. So you can say turtle.setHeading 0, and it'll always be facing right. Maybe that's something that will be interesting for you. So Discord, finally, after I explained all that, good timing, has opened. So let me give you this code on Discord if you'd like to get it there. But I'll just leave it open as well. See if you can draw a second square somewhere else. And don't make any stray marks. Oh, it's still trying. I'm sorry about that. I'll just leave the code up here while it thinks about starting up. Here's my square. I'll give it to you eventually. There it goes. My computer is absolutely not happy about having Zoom and recording and all this stuff. But, okay, Zoom, go away. Oh no. There, you have my code now. I'm closing Discord before it goes horribly wrong. Yeah, here's most of it, and then some ideas. I think that's what I want to do. So I'll give you a few more minutes to give this a try. We got plenty of time. And please yell at me if you have any questions. If you do it super quickly, see if you can read the documentation page and figure out how to change the color. The color of the lines that he makes. That might be something to keep yourself from getting bored. I'll show you that eventually. Another minute or so to give this a try, then I'll show you how I might do it. Alright, that's my timer. Were there any questions that came up as you tried this? Did we all get a square? Alright, so where do I want to put my square? Maybe I'll put one, I don't know, to the right? Sure. To the right of my current square or something? I don't know. I'll figure it out. So that's what the turtle looks like right now. Let's say I want another square over this way on the right side of this one. Maybe I'll make a tinier square to the right. And so I kind of want to, maybe I want their bottom lines to be along the same line. So I kind of want to move the turtle over to here. So there's like a gap between the squares and start over. And so here is how I might think about doing that. If I would like to just no matter what direction the turtle's facing, I don't want to deal with calculating whatever that is. I could just say, turtle, well, first of all, let's draw a second square. I can just say turtle.setHeading 0, and that always means wherever you are, turtle, go and face east now. Go and face to the right. So that's going to be the first thing that I'll do. If I run this. Whee. And by the way, if you would like the turtle to move faster, there is a turtle.speed. You can say at the very start, in addition to controlling the way he looks, you can control his speed and say something like turtle.speed, and then you can give like slow, fast, fastest, or something. But I'll say fast. Make the turtle go fast. I think the default is like some medium amount of speed, but now he moves faster, and so it's easier for me to get to the same spot. There he is. And so now I kind of want him to move over here to the right and start a new square. So maybe I'll move him over like 150. Turtle.forward 150, because then I'll be in a new spot to make another square. But, of course, there's a problem with that. His tail was down, so when I made him go over here, he's going to make that line. Some extra marks there. And so if I want him to move without making a mark, I say turtle.up. Pick your tail up, turtle. Then move without making a mark. So now he's over here and there's a gap. That's important. All right. And now when we want to make more marks, we can say turtle.down. Put your tail down. Okay. And so now if we make a square, it's like, all right, go forward 25 or something. Turtle.forward 25. Now he's going to make a mark in a new spot. There he is. So he makes a very tiny square. And so he's got to go left by 90. Turtle left 90. And then turtle forward another 25. Oops. After that. Cool. And then I'll just finish it off. Another left 90, forward 25, twice more. So we got 2 more lines to draw. And so there we have like a very large square and a very tiny square. Are there any questions about how I did that? Is that kind of how you did it too? So I will, of course, share this code with you. And we just asked a cute little turtle to make drawings for us. That's going to be our topics for a while from now on. All right, we get to move on to a more complicated example. Okay, so yeah, next idea. Let's draw a triangle. Slightly harder than a square. So let's draw an equilateral triangle where every side is the same length. That's a bit easier. But now we have to deal with angles, right? Because it's not left 90, right 90 anymore. It's going to be some weird numbers. Okay, so here let's pretend that we're going to draw an equilateral triangle. So every side is of the same length, and that kind of forces an angle on you as well. And let's see here. If it's equilateral, that means, I don't know. First of all, let's start it at 0, 0 as usual. And let's pretend that every side length is going to be 200. 200, 200, 200. And when it's equilateral, when every side is the same length, like these are all 200, 200, 200. That also means that every angle is the same. Like each of these angles, they are all the same, which makes it easy on us. We just have to figure out what they are, okay? Does anybody know, or can deduce quickly, what is this angle? 60. Good. Yeah, 60, because every triangle was made up of 180 degrees, and if each of these is the same, it's just 180 over 3, so 60. Good. So this is a 60-degree angle in here on every edge, every little corner of that triangle. Okay, so let's make this happen. Let's start the turtle at 0, 0, move him right by 200. That's his default direction. So that's a good start. Let's get that bottom line going on this triangle. Where is my square.py? So I'm going to copy and paste most of this into a new file. I'll call it triangle.py. I'll steal a lot of it. Triangle.py. So there's triangle.py. I'll get rid of all my drawing stuff. So if I want the bottom line of this triangle to be 200, I'll be like, hey, turtle, move forward in your current direction, which is right at the beginning, by not 100 units like the square, but 200 units. Okay? So now we're over here, and now I just need to like turn him and draw the upper part of this triangle. So let's do that. So you might think it's like turtle.left 60. Let's watch that. Turtle.left 60. And then, of course, the other side is also 200, so it's turtle dot forward 200 after you move. Something like that, right? But that is not what we want. Turtle dot left 60. That's less than 90, so he's not even going to go straight up. He's going to go more to the right. Do you see the problem? We wanted the turtle, like he was going to go this way if we didn't move him. He was ready to just keep going right? And so we need to turn him, not by 60 degrees, but by whatever this is, this amount. You see that? That's the other side of this line. So you have to remember your geometry. It's like this is 180. These sum together is 180 because it's a straight line. So whatever this angle is going to be 180 minus 60. You see that? That's the goal. So it's going to be 120 degrees. That's how far the turtle needs to move left. And then it'll be in the correct direction to move forward and draw the right side of that triangle. So it's not 200, but it's not 60, but it's 180 minus 60. And you don't have to compute that. You can just let Python figure out that it's 120. You can have it do the math for you. Isn't that nice? And so now we have a nice looking triangle almost. And it's very similar to the square in that you want to keep turning by the same amount. So it's going to be another turtle dot left 180 minus 60 again, and then a forward 200. If you think about it long enough, that is what needs to happen. And that will give us our beautiful equilateral triangle of side length 200. Any questions about this example? See how we had to calculate what needed to happen? It wasn't the obvious answer. It wasn't like turtle dot left 60. It was turtle dot left 180 minus 60. It's kind of cool. So a slightly more complicated example there. Yeah, are we good to keep going? I have the most complicated example for the end today. All right, so this is going to be similar to a future assignment that I give you, maybe today. I forget the ordering. This might be today's assignment that I assign. I would like to draw my initials. I'm going to eventually ask you to draw your initials. So you can just draw it with straight lines when I ask you to do it. But I'm going to draw an L and an N because those are my initials. Okay? So the L is super easy. It's just like a rectangle. Boop. So this is like the drawing that I want to make. Like an L and then an N with some space in between, of course. I'll try and draw as straight of lines as possible. Let's pretend that this is the drawing that I'd like to make. Okay? So, assuming I want to make this, I first of all have to figure out where I want to make it on the screen, because the turtle starts in the middle. Do I want to have the L immediately start the L right there? That might be a bad spot. Maybe you want to move the turtle over instead of starting here and drawing the L. Maybe we want to move the turtle a little to the left so that he starts drawing the L over here, and now it's more in the middle of the screen. So that might be a good goal. Let's do that. We also have to pick how big and wide we want these letters, right? We have to pick the lengths of all this. Maybe the turtle should start up here, but we got to move him down, right? And how much is the question. So let's pretend that we pick these numbers. Let's pretend that the height of the L is 200 and the width of the L is 125. Actually, the width of both of these characters, let's make it 125, just so that they look uniform. So this is also 125, and of course the height of the N should also be 200, just to make it look normal. Now we have to also pick, what in the world is the gap? What's the distance between these letters? What do we want that to be? We have to pick all these things. Let's pretend that we want this gap to be, 40 units. I'm just picking random numbers, okay? Could be whatever you want. So let's get started. The L is going to be super easy. It's just like a square, just a box. Just turning 90 degrees and stuff. But the other ones are going to be hard. So let's see here. I'm going to need a new file. And I'll call it initials.py. I'll copy and paste most of this, though. Okay, so I kind of want you to see how this works, so I'm going to comment out this line. So it's no longer going to run, it's just now a comment. So it's not going to go faster anymore, it's going to be the default speed. And I guess the first thing that I want to do is get the turtle, instead of starting somewhere, like in the middle of the screen, drawing the L there, because it's going to look like it's on the right mostly, let's get the turtle into some position on the left of the screen. Get the turtle into position. And because we can keep running this, we can like play around with it. But I want to move the turtle somewhere to start drawing, and I don't want him to make any marks as he goes there. So I'm going to say turtle.up. And now I'm going to move him. So I guess the first thing that I could do is say turtle.set heading 180. Because set heading 0 is facing east, 180 is going to be the opposite direction, facing west. And so if I run this, the turtle is going to be facing the left. And I want him to move a little bit to the left because I want to start my L over to the left there. All right? That's going to be my goal. So let's say turtle.forward like 200. Let's see how far that gets us. And of course, you can play around with these numbers. Is this a good spot to start the L? That looks good enough to me. Let's see here. But kind of, we don't want the L to start here, because like if we start at the top, it's going to be like mostly on the bottom of the screen. So maybe let's move the turtle up a little bit and start the L like up here. Okay? So that's going to involve moving the turtle to the right to make him face up. So turtle dot right 90 degrees to the right. And so now he's facing like this. Let's move him up a little bit. So forward 100-ish, I don't know, 200-ish. Let's say 100. And I do believe this is a nice place to start my initials. All right. So I'm going to start my turtle right here at this dot, and then that'll be the top of my L. Okay. So now we're in position. We're ready to draw. And so I want to start making marks from now on. So I'm going to say turtle dot down. Right. Put your tail down. Now we're ready to start drawing. Okay. And so then we're going to draw the L. Whatever that entails, which is going to involve, I guess, we have to like point him down now, face downwards, and downwards would be turtle.set heading 270 if we didn't want to think about relative to his current position, his current angle. So turtle.set heading 270, that would face him south, and then I believe that's a good place. We can just start drawing our L now. So now he's ready to go forward, and we said that the height of the L should be 200. So forward by 200 now. Too many windows. Turtle.forward 200. There he goes. So that's the L, and then we want him to move, turn left 90 degrees and go forward by the width of the L. And then turtle.forward, I think it was 125 we said. That's how wide we want our L to be. Let's confirm that, yeah. And so I think that is good enough. Yeah, so now we got an L. Any questions about that one? Just like a box. Not too hard. Now, I would like to have some space between these letters, right? So I can't just say the turtle's already in the right direction, first of all. I could just say go straight by 40 if his tail was up. But his tail is down right now, and so I can't say go straight by 40 because that would make a mark. So I want to pick his tail up before I make that gap. Let me see that. So we need our space between letters. Oops. Which involves pick your tail up, turtle. Then we can go forward by, I think it was 40. Let me move this up here so everybody can see. And now I think we're in a good spot. So the up was very necessary. There we go. Now we have the gap, and we're ready to start with the N. So now we're ready to start drawing again. So we can say turtle.down to make some more marks. And now it's time to draw the N. Okay, so this is definitely going to be the harder one. So let's plan this out, okay? Because the idea is, like, we start here. Our turtle is right here at the beginning. We want to face him up. That's easy enough, right? So face the turtle up and go forward by 200. That'll draw this line of the N. We can do that at least. So let's do that. This turtle's facing to the right, so let's say turtle.left 90 to make him face straight up. and then turtle forward by 200 to draw the first line of the N. Cool. And so now the question is, and the very important question is, here's what's going on with the turtle. He is currently facing up. We would like him to face this way, right? Down and to the right, this diagonal direction. So there's a big question to think about now. Like, we need to turn him by this amount. And so what in the world is that amount? It's going to involve subtracting from whatever this angle is right here. And that's a big question mark too. What in the world is that? Because that's going to tell us what we need to do here. Okay? Does that make enough sense? So, how can we do this? Does anybody see? Like, how can we determine like what this angle is? Because we need it. It's not 90 or anything. It's not 45. It's nothing normal. Yeah, we're going to have to use geometry. So maybe you thought you never needed that again. We're going to have to use our SOHCAHTOA stuff, sadly, because what is this? What is this angle but part of a right triangle? Ooh. See that? Thought you never needed this knowledge in your brain ever again? You need it now. So, to draw pretty pictures, you need it. So, here is this is the hypotenuse. This is one side. We know the side lengths, the 200, 125. You can figure out what that is by the Pythagorean theorem if you needed to. We're going to need to, actually. So, we just need this angle right now. So, we have the opposite and the adjacent. What's that one? That's tangent. So, that means if we wanted to know what that question mark angle is, we know that whatever it is, the tangent of it is opposite over adjacent. That's 125 over 200. Fun. And so obviously we can figure out this angle by taking the inverse tangent of both sides. So now the question mark angle is inverse tangent, which is disgusting, of 125 over 200. We can calculate all that. And there is a math library function that does this for us. So that's where we need to go. So turtle Python math. We need the math library now. If it wants to load. I sure hope I haven't lost the internet. Oh man, I think I have. It always happens at this time too. It's so odd. Okay, sorry about that. I'm gonna need to show this page too, so I guess I'll just disconnect from the Wi-Fi and try it again. That's gonna ruin this. It's gonna ruin the Zoom session. It's gonna ruin this connection to the display here. But yeah, just give me a minute. I'll make it work again, in theory. It's trying. Oh wow, it connected, but it's still not happy. Okay. Oh, there it goes. Okay, cool. I think I can start everything again. Hopefully the Zoom window came back. But let me connect to the projector once more. This is fun. Alright, that's at least all the internet I think I need for the day, in theory. So here is, you can search for Python math and get the math library documentation again. And if you scroll down, go down here, Zoom. If you scroll down, there are your trigonometric functions, and here are the inverse ones. The inverse tangent is called atan, or arctangent. So you say math.atan, whatever you want, and that'll give you the answer, unfortunately in radians. I say unfortunately because we turn the turtle with degrees, right? We're getting the answer back when we say math.atan. We get that back in radians, sadly. So let's at least get there. This is given to us in radians. Oh no. So that's that. Let's at least get that far. So we need that angle, definitely. So let's compute it. We're going to have, all right, the angle that we need is equal to math dot atan. Right? It's the inverse tangent of 125 over 200. 125 over 200. And this angle is unfortunately in radians. But the math library can convert from radians to degrees. There's another function for that. Forget what it's called. I think it's just called degrees. You can say math.degrees of some radian angle, and it will convert it. That x from radians to degrees. So if I just wrap this whole thing, like whatever this is, it's a radian amount, wrap it around a call to math.degrees, that will give me the degrees form of that angle. All right? Well, that's what we want. That's the angle we need to draw that n properly. All right? So now, again, I would like to not go, I need to turn the turtle to the right, not by that angle, but by 180 minus that angle. Again, you see that? So go right by 180 minus the angle, Mr. Turtle. Turtle dot right, 180 minus angle. And it should look like he's lined up now. Oh shoot, what did I do wrong? Math is not defined. Oh, I need to import math at the top. Forgot that. Obviously, it doesn't know about it if I haven't imported it. And now he's angled. He's angled properly, ready to draw the rest of the n. And now we need to know how far to go forward. So I need this length here. Like, what is the length of this hypotenuse? And that is, of course, Pythagorean theorem. So we have L squared, that is the hypotenuse, equals 125 squared plus 200 squared. And if I want just L, I can take the square root of both sides. So L is equal to that square root. 125 squared plus 200 squared. Let's do that. Math.sqrt. That's the length. So here's my length. L is equal to math.square root of, let's see if I can get all this on one window. There we go. 125 squared, we know what square does. It's star star for power of 2. And then plus 200 squared. So there's my length. And I'm going to go forward by that length. Turtle.forward L. Thank goodness. I believe it is happy. Nice. And it's perfectly aligned. And now we want to turn the turtle left by some amount. And it's going to be the same angle if you think about the geometry. We want to turn the turtle left, not right this time, but left, by that same angle that we turned him to get started on that part of the end. So now he's going to be facing, in theory, straight up. You could also just say turtle.set heading 90 or something, but this was more fun. We calculated that. And so now he's going straight up. We can say forward 200 one last time to finish off this N. Oh, yeah. So that was fun. Are there any questions about all the fancy stuff that needed to be done to get this far? That was the N. Definitely harder than the L. Okay. I taught you this the hard way so that I can show you the easy way later. That's how most things work in life, right? You can cheat. There's a turtle.goto function that would make this so much easier. But I wanted to show you it the hard way so that we can get practice with Python. So there's a turtle.goto. Where is that? Documentation page. Turtle.goto, or set pause or set position, whichever one you want to use. You say turtle.goto, and then you give a coordinate. And the glorious thing is that the turtle just kind of drifts to that coordinate. It doesn't matter what his current direction is. You can say turtle.goto like 0, 0 or something, and he will just go straight there, take a straight line path to that coordinate. So at the very end, I'm asking him to go to 0, 0, and he just drew a line. He just kind of drifted, even though he was spacing up. He just drifted over to 0, 0. Okay, so that's going to make it easier for you, but I wanted to show you the hard way first. All right, so I'll comment that out. Back to our pretty picture. But yeah, think about using goto. Just read the documentation page. There's a lot of helpful stuff there. Okay, so that is my initials. And that's the code, and that's the scratch work. Any last questions about any of that? There's a lot going on there. But fun. I encourage you to try it and play around. It is very rewarding to get it right. I hope I've convinced you of that. So if we're happy, the very last thing that I want to do for the day is talk to you about your next programming assignment. I will release it, assuming I still have internet, which is a big if. It's trying so hard. No clue if I clicked it and it worked. No clue at all. I doubt it did. Darn. Well, this is fun. I'm sorry you guys have to deal with this horrible internet that I have. Let me try just a different network, I guess. I'll try this other network, whatever this is. Maybe it will be happier. Is it happy? Is it still connected to the... Oh, that's nice. So, alright, I doubt it worked. Let's see. I doubt it published itself. That's what I meant. Looks like it's... Oh, cool. Alright, so published. Hopefully it works now. So, here is your next programming assignment. This will be due, I guess, the 16th. Is that... That's next week, so it's just a one-week assignment. Not too bad. You can use my examples from today, of course. So I would like you to write a program that uses the turtle library that, as big or as small as you want, it draws your initials, first of all. And you can use just straight lines. If you have like a J in your name or something, that's one of your initials. You don't have to like learn how to do the curvy drawing. You can just make that a bunch of straight lines if you'd like. No problem there. I want you to draw your initials like I did today, but I also want you to draw the year that you expect to graduate. So like just the last two. So like if you expect to graduate this year, maybe you can say 2-3 at the end. So like for example, if I were to complete this program, I graduated college in 2020. I would be drawing LN20, and I can draw any of those as big or as small as I would like. That's the goal though of this program. Draw your initials and the year you intend to graduate, either from here or from a 4-year college, whatever. Yeah, you don't have to use the fancy angles like I did. Look into using GoTo. You don't have to use curvy lines if you don't want to. That is completely optional, because I know that's a bit harder. But there is like a turtle dot circle method that draws a portion of a circle, which would look cool, but I'm not requiring you to do it. I think it would be fun, though, to learn it. I could definitely help you. So here's an example of like my initials, and then next to that you draw like your graduation year, like a 2 and a 0 for me down there. Right? Don't forget the digits in yours. I haven't given you everything. So if you have an L or an N in your initials, you're welcome. But the rest of you will have to do it all from scratch. Okay. So let's see here. Your submission, of course, as usual, will be a video. So please make a video of you running your program. I want to see the turtle draw your initials in your graduation year, and I will enjoy watching that. And also just like show me the code, of course. Show me the code, explain to me that you understand how it's working, stuff like that. Okay, doesn't have to be long. I just want to see it and hear from you. Okay, so could be as short as a 30-second video if you would like. So are there any questions about the requirements for this program? Definitely look into my code. I post everything that I write in class. You can use a lot of that from today. All right, if we're good with that, those of you who I have been giving other assignments to, if you have programmed before, from now on I want you to do the Python stuff, because I don't assume that you know Python. Please do this as well, just like everybody else. But of course, if you've programmed before, I think you can do cooler things. So look into like changing the colors, look into using the curvy lines, and I can of course help you. So like put in as much effort as somebody who's brand new would have been putting in. Okay, that is your goal. So yeah, all of us are going to do this assignment from now on, the Python stuff. Any questions about any of that? So this will be due next week. Week and a half-ish from now to do it. Okay, so I believe that is everything that I wanted to talk to you about today. The rest of the time is yours to get started on this if you'd like. Let's see here. Stop that. And that's published. Yeah, question? You might just have to install it. Does it work? Like, does it show you a Python? And then that's slow is an option. Just like I said, turtle slow with input. Something. There's a function that keeps it open if you have a program like that. Python turtle. Okay, so the very last thing you say is if you want to keep it open in that form. Last line. Thanks. Oh, sorry, I should stop recording.